All right, let's go ahead and get started with the Introduction to Web Dev quiz number 7. This one, we're going to be going over databases, SQL, SQLite, auto increment, and unique/primary keys. Bunch of fun stuff. Cool. Let's get started with that first question. If a column is assigned the auto increment constraint, this means A, each value in the column needs to be unique. B, when inserting a new row, the value gets added onto from the previous value. C, the value in the column can't be null. Or D, when inserting a new row, a default value is used if one isn't provided. The correct answer here is B. Yeah, so auto increment, you can kind of think of this as when we increment, what we do is we just add one onto that previous value, and this is done automatically. So if you wanted to, say, have this table where, we have the ID and the name, and we say that the ID should auto increment, what we're saying is every single time a new entry is added, just increment that ID by 1. So here we've got this insert statement, and we're inserting into the people table. We're inserting the name, and the value is Tom. Let me get a different color. It's a little hard to read. The name is Tom. And notice here we didn't even add in the value of the ID. The reason for this is because that column is auto incremented. So we see, okay, in the last column, or in the last row, the value of ID was 2. We're going to add 1 to that to get 3. So that's auto increment, pretty handy. If you're writing a lot of these insert statements, you don't want to constantly have to be like, oh, okay, well, the next ID is 3, and you kind of have to keep track of, okay, so what was the last ID number? So this is really helpful because you don't need to keep track of stuff like that. These other 3 options are properties that you can set on your columns when you're creating that table, but they are not the auto increment constraint. Cool. Next question. It's redundant to constrain a column to be a primary key and also unique. The correct answer here is true. Yeah, so this is correct. So when we have a primary key, what we say here is that key, it cannot be null. Right, there has to be a value when you insert a new row into your table. It cannot be null. And we can only have one of these per table, one of these values. So say, for example, my primary key, like what in the last example was ID, and let's say I didn't have the auto increment on. Let's say I entered some row that had the ID 1. What we're saying is there cannot be any row that has that same ID. The ID has to be identifiable. So if, for example, we tried to enter another row with ID 1, your database would probably throw some more sort of error and be like, oh, it has to be unique. Same with if you put in a null, because how can you reference a row with a null primary key, right? So this is slightly different than a unique key in that a unique key, you can have one null value per table. So what that means is, let's say we've got some sort of name column, and we set the property unique on it. That means that we can have one null name in the entire table, but we can't have another one, right? Every other one has to be an actual name. So for example, let's say it's like Olga or something like that. And another difference between the unique key and the primary key is you can have multiple of these unique keys per table. So let's say in some sort of weird database, you won't have more than one person named one thing, right? We're going to say that's unique. Let's say, for example, you also want just one person of each age, and you said that is unique as well. It's okay for these to both be unique, as long as these both aren't primary keys. And like this last bullet says, it's useful for fields that are not a primary key but should still be unique. All right, next question. The SQL statement delete from menu, where menu is a data table, does what? A, deletes the menu table. B deletes the first row in the table, C deletes everything in the table, or D deletes the last row in the table. The correct answer here is C. Yeah, you might think it's A. I certainly, when I was learning SQL, would have thought it was A because, that would make sense, right? But no, it actually deletes everything in the table, but the menu table still exists. It's just empty. What you might be thinking of that deletes the menu table is drop table menu. What this does is it deletes all the data in the menu table and also the table. So this is like, don't use this command unless, you want to cause a ruckus. Here's this cartoon that I've seen probably 10 times in my CS education where, a school calls and they're saying, your son caused some damage. Did they break something? Did you really name your son Robert drop table students, where like students is probably some sort of table that exists in their database. They say, yes, little Bobby tables. And then the person on the line says, we've lost this year's school records. I hope you're happy. And they said, I hope you've learned to sanitize your data inputs. It's so funny. It only gets funnier after you've seen it the 20th time and your CS professor is like, look at how funny this is. And you kind of have to like pretend to laugh. Anyway, drop table menu. This drop table command, super, super dangerous. I can imagine any school that lost all their student records would not be too happy about that. But delete from menu, sometimes you'll put like a where clause here, and then like some sort of column matches some sort of condition. But here, since there's no condition, what we're saying is, okay, well, every single one of the rows fits that condition, so let's get rid of all those rows. All right, next question. db.all returns A, nothing, B, an array of JavaScript objects, C, a JSON object, or D, a string. The correct answer here is B. Yeah. So db.all is a SQLite method. So for example, if we have this query here where we're saying select the name and the color from some cats table, it's a asynchronous command where we do db.all that query. So then SQLite will kind of run through the cats table and return this array of JavaScript objects. And this can be really helpful, let's say, for example, you're doing this somewhere within your website and you want to display this information. What you can do is you can just sort of run through the array using like a for loop, while loop, etc. If it didn't return anything, that would be a bit strange, seeing as how this is a method for querying a database or a table. It's correct. B, an array of JavaScript objects. Next question. Connecting to the database in app.js should be in a try-catch. A, true, B, false. The correct answer here is true. Yeah. So, like I've said in the previous quizzes, we want to put things in a try-catch that could potentially fail, that has, it won't 100% of the time succeed. And we never know with databases. So there are many, many things that could go wrong. Say, for example, the server's down, the database is missing or corrupted, or, you didn't put the right username or password. All these things could go wrong. And in that case, we want to catch that error. And, if this is an error that is happening when our user is trying to use our website, we might want to display some sort of error that's like, couldn't perform this transaction at this time. Please try again. So, if, for example, you didn't do this error handling, let's say, for example, you were, trying to withdraw some money or deposit some money in your bank account, and it didn't actually go through, and you think that it went through, but your bank never said anything otherwise, that would be pretty terrible, right? Your relationship with your client would tank very quickly. So, as I've said before, always make sure that you're catching these errors and you're propagating them up to the user so that you don't have an upset user. And that concludes the first part of the Introduction to Web Dev series, quiz number 7A. Hopefully you learned something. Hopefully you got some questions right. If you didn't, it's okay. It's not the end of the world, you know?